Okay, I see a good number of people are still connecting. Well, hi everyone. I do not know most of the people on this webinar, but I'll start with a claim. You're all spending too much on your cache and in-memory workloads. You can reduce it by 30 to 80% in a few days of work. So I'm Oded Pons. I'm the CEO and co-founder of Dragonfly DB. Before that, I was an engineer at Google and a CTO and a co-founder of 2 other startups. In the last 25 years, I've been building very efficient and scalable infrastructure. And my previous company, we had an order of magnitude lower infrastructure cost than industry standard. And after the company was acquired, I reduced the infrastructure cost of the parent company by 30% per year. And it's not only me, like controlling cloud cost is top of mind for many of us. Nowadays, every company has a KPI for cost saving. This is becoming so important for companies that companies are hiring FinOps engineers to control cloud cost. So today I'm not going to suggest to leave the cloud because it makes no sense. But how do we control cloud cost? So my philosophy for that is that, first of all, you need a very good cost monitoring system. It can be Grafana, it can be CloudWatch, it can be proprietary, whatever you have. The second thing that you need is a constant process to choose the low-hanging fruit. So a project with a short time ROI, a project that returns its investment even during the same months of investment or the same quarter. On the slide here, you can see like the 3 major cost factors of cloud spend on the 3 top clouds. Most companies are reducing compute costs by reserving spot instances or buying reserved instances. Basically, 60% of the workloads on the cloud is reserved instances. Without it, the compute cost here would be around 40%. But after this trivial improvement, most of the optimization would come from your data. For cost optimization, this is what we should focus on. In many cases, optimizing the data component has a surprising effect also on storage and compute. So today, we will focus on how you can reduce your spend on real-time data. And when I say real-time data, I mean your high-throughput, low-latency data. Since 2009, this means Redis. Even if you're using Elasticache or Google Memory Store, you're still using Redis. Even if you're using Valky, you're still using Redis because this is a fork. Typically, it's common to see organizations spending between 10 and 40% of their data cost on Redis-like solutions. So back in 2009, when Redis was created, the world was very much different than the world today. Vast majority of the instances had a single core. GCP and Azure didn't exist. Only AWS existed on the cloud. And the largest instance that you can get had 4 cores and 64 gigabytes of memory. The entire world produced only 1 zettabyte of memory during the entire year. Today, data is booming and hardware has at least an order of magnitude stronger performance than it used to have in 2009. Yet most of us here are still using Redis technology from 2009 that is single-threaded at its core and cannot utilize this modern hardware strengths. And this is wasteful. To begin with, Redis is wasteful in its memory usage. And memory is expensive. We will get back to that later. But modern hardware memory always comes with CPU. Typically, cloud instances comes with a CPU to memory ratio of 1 to 2, 1 to 4, or 1 to 8. So if you need 100 gigabyte of data, you will end up with an instance that has 16 or 32 cores available for you. And Redis is not built to use this extra core of modern hardware, as it's single-threaded at core. To scale efficiently on Redis, you will need to take like 16 instances with 4 or 8 gigabyte of memory each, which again is wasteful and complex. Because Redis was designed to work with common hardware that used to have a few gigabytes of memory and only a single core. To scale for more than a few gigabytes or 10,000 requests per second, you would need to use a Redis cluster. So now with Redis cluster, you have many wasteful instances and a complex production to support only because you need 100 gigabytes of memory. Does anyone here has a Postgres with 100 gigabyte of memory that's distributed over 8 shards or 18 nodes? To recap, memory is expensive. Redis is not memory optimized. It's not CPU optimized. And it adds complexity to your production. Luckily, we created Dragonfly. So Dragonfly is a multi-threaded Redis drop-in replacement. It was designed for efficiency and scalability. It delivers 25 times better performance than a single Redis node because it can scale vertically first. It doesn't mean that we do not support cluster, but every shard in the cluster can scale vertically to support much higher workloads than Redis. One extreme example that I have for that is one community users of Dragonfly replaced 128 nodes Redis with a single Dragonfly. So let's see how Dragonfly can save big time. First, let's see baseline pricing. Let's assume that we have a 90 or 100 gigabyte of data that we need to serve. And see the pricing on Dragonfly and on Elasticache Bulky. So let's see here. This is the pricing of Elasticache. So for 100 gigabyte memory, I will need to take this cache R7G 4 extra large instance, which basically costs like $1.4 per hour, which basically means more than $1,000 per month. Okay, so this is what I took here. You'd see that I took a R7G 4X large, that has 105 gigabyte of memory. And let's see what I took for Dragonfly. So for Dragonfly here, I took a 100 gigabyte data store, which basically cost, let's see here, as you can see here, a 100 gigabyte data store cost $800 on Dragonfly. But this is represent like a 20% lower price of Dragonfly versus Valky. It's still not the 80% that we talked about at the beginning. So now let's see how Redis and or Valky, what they actually deliver on the cloud. So Redis and Valky and so is Dragonfly are bounded by the memory. When you get to the memory limit of the instance, keys are evicted or you get out of memory errors. Let's inspect the memory that we are actually getting from Dragonfly or from Elasticache. Okay, so I have here basically I'm connected here to both Dragonfly on the left side and Valky Elasticache on the right side. And now let's run and see the max memory that we can get from Dragonfly. Okay, so I'm running an info memory command and grabbing only the max memory. And as you can see here, we provide in Dragonfly for 100 gigabyte data store, we actually provide 100 gigabyte of memory, or in the binary form, 93 gigabyte. Let's do the same on Elasticache. Okay, so what you see here with Elasticache, that you're actually getting an 85 gigabyte of data store. And as a reminder, we saw that it's actually 105 in the documentation. So we actually have on the machine only 85 gigabyte of memory available for us. So now we are left with an option. Like either we need to use less data, which is not an option, or we need to take the next level of an Elasticache instance, which is basically R7G 8 extra large, okay? But this one already costs $2,000 per month. So basically, just with those two things, Dragonfly is like 60% lower in price than with Elasticache Valky. But let's move on and see, because with Dragonfly, we also use the state-of-the-art data structures so that the overall of holding the data in memory is minimal. So let's see it in action actually on Dragonfly versus Valky. Okay, I'm going back to the connecting to Dragonfly, and what I would like to do is to basically use sorted sets and add 10 million items into sorted sets on Dragonfly and also on Valky. So the left side is Dragonfly. Okay, so I'm using Mentir. and I'm sending data to Dragonfly. And now I'll do the same for Valky. Okay, so you see here also the average QPS or operations per second. This is not a presentation where we need to notice that. Actually, we care here about how much memory we would take for that. So let's see how much memory we are taking on Dragonfly. Let's grab the used memory. And you see here that on Dragonfly, the used memory now is 561 mega, okay? It takes a bit more time for Valky. Basically, I tested that only on items that are 10 bytes long. Okay, Valky just finished. And okay, the use memory on Valky is like 1.06 gigabyte. That's much more than Dragonfly. Let's flash the data stores, okay, clean them from all the memory, and do the same experiment now with items or values that are 100 bytes long. Okay, so I'll do that on Dragonfly, and then here I'll also flush the memory of Valky and run it from the beginning with 100 bytes of items. Okay, this might take longer. Again, you see here the operations per second. It's not that it really matters, but Dragonfly will end soon. Yeah. Okay. Let's see now with Dragonfly. Okay, with 100 bytes long items, the used memory on Dragonfly is almost 1.3 gigabyte. Okay, let's not wait for Elasticache. Let's just move on. So I have here the table that shows the memory efficiency of Dragonfly or Dragonfly data structures. So basically, when we are adding items to assorted sets, if those are 10 bytes, you would save like almost 60% with Dragonfly. If those are 100 byte, you would save around 34% with Dragonfly. Also same for strings. If just you're using a simple key value, so with a 10 bytes key value on Dragonfly, it would be 500 mega, and on Valky it would be like 890 mega, which is 42% saving on Dragonfly. And if you're using 100 byte values, so Dragonfly would save 21% of the memory. So think of what we saved so far. Like we started with 20%, then we added around 60% because what you are really getting from Elasticache is much lower than you see on the website. And then because of the optimized data structures, you save much more with Dragonfly. That can be an additional 60%. And the best thing is to see it in action from an actual client of us or customers of us. So they had 310 gigabyte of memory on Redis. And then with Dragonfly, they have only 169 gigabytes. So think of the saving that they made. So we touched the memory efficiency, but we also said that memory always comes with a CPU. So here on the top, you can see that how Dragonfly utilizes all the cores on the machine to handle the load. So this allows every single shard of Dragonfly to perform as a Redis cluster. This is how you get 25 times better performance with Dragonfly versus Redis. You would see here Redis at the bottom. So Redis utilizes only a single core out of this 8-core machine. And so you cannot get to the performance that you would get with a Dragonfly. And when I say here Redis, it's also the same with Valky. And it's not only the hardware that is being saved. Think of the simplicity of setup, monitoring, maintenance, upgrade, recovery. This is all part of the total cost of ownership that is saved. To me, it's also kind of a cognitive relaxation to use Dragonfly, because I don't need to know all those Redis or Valky instances that are running. I just need to know a single or a few, or a cluster of a few Dragonflies that are running. And so cost saving is also only half of the puzzle. To determine the ROI of any cost saving, you also need to calculate the cost of implementation for the cost saving. Okay, so Dragonfly is a 100% API compatible with Redis, meaning that the migration can happen in a few hours, not weeks or months. So the investment that you need to do in order to switch from Elasticache or from Redis to Dragonfly is basically a single DevOps engineer for a few hours or a few days. And the saving of 80% is so big, so the ROI that you would get on this investment comes in the same week or in the same month or the same quarter. So to recap, Dragonfly improves your cost because it's basically its base pricing is lower because of its optimized data structures, because all the CPUs that comes with the memory are utilized, because of the operational simplicity to reduce the complexity of your infrastructure, and so the total cost of ownership. And because it's a low-hanging fruit to migrate with a high ROI. So I hope this was helpful to understand how you can reduce your cloud cost and especially your data cost on the cloud. And you don't need to leave the cloud. Basically, the only thing that you need to do is to go to Dragonfly Cloud. You can scan this barcode and get a $200 credit on Dragonfly Cloud and start optimizing today. Laura, do we have any questions coming from the crowd? Okay, Go ahead, Laura.
We have one there after coming through from the community. What are the differences between Dragonfly and Valky, and when should you use Dragonfly over Valky and vice versa?
Okay. So that's a good question. So basically, as I said, Dragonfly is a drop-in replacement for Redis with the same API, but it's also a drop-in replacement for Valky, because Valky is basically a fork of Redis 7.24. Currently, they have the same API, same everything. So you should use Dragonfly instead of a Redis or instead of a Valky. You also asked when should you use Dragonfly versus when should you use Valky. Basically, Dragonfly, you can use Dragonfly on all use cases versus Valky or Redis, but Dragonfly was designed for the heavier workloads, okay? So workloads with more than a few tens of gigabytes or a few tens of thousands of queries or operations per second. Laura, any other questions that we got? We cannot hear you. You're on mute.
So this is one question from our community member, and how can you claim that it's faster and cheaper than Redis? I think a lot of the stuff that you've demonstrated today shows that, but we have also documentation on our website as well.
Yeah, well, basically, it's both more throughput and better pricing than Redis. It's the entire presentation, but basically this all comes from the underlying technology of Dragonfly. Okay, with Dragonfly, with a single Dragonfly, you can replace a Redis cluster because Dragonfly is multi-threaded, so we can utilize all the cores. That's one element of that. The second element is that Dragonfly data structures are optimized for modern hardware. So it optimized for CPU usage and also optimized to reduce the memory consumption. Both optimized CPU and optimized memory means better performance and better cost. Laura?
Thanks, Odette. And our final question for today comes from Reedy Paul. Looking for ways to speed our web apps using Redis-like applications. We have millions of records and wanted to explore ways on how Dragonfly will help us in our app building process.
Okay, so yeah, so basically when you say here, you didn't say where those records are stored, but let's assume that those records are stored in a database or something like that. It's kind of easy to upload them into Dragonfly if you use Dragonfly as a cache, or so you'd have Dragonfly as a write-aside cache for your data store. Basically, what you would do is you first look for the key in Dragonfly. If it's not in Dragonfly, so you go and query the data store. You take it from the database, you upload it to Dragonfly, and then you return the answer to the user. The next time you come to Dragonfly, you would see it on Dragonfly. To have millions of items on Dragonfly, this is a no-brainer. I just show as part of the presentation how easy it is to upload 10 million items into Dragonfly. It just took basically a minute or so, or actually 10 seconds or so. So basically, if you're basing your new infrastructure on Dragonfly, I think that this is a very good choice. and it's very easy to load 10 million items to Dragonfly and start using it immediately.
Thanks, Uda. That's all the questions for today.
Okay, so great to have you all here, and see you next year, I guess, in 2025 on our next webinar. Bye-bye.